just going to talk through these answers about the gardening question. We've got the time for the weaker pellets to dissolve at different temperatures. And Jo's done this experiment and she's got the water at different temperatures, timed how long it takes in minutes, and recorded all that data, and found a linear model. This is the equation, 5.95 minus 0.0873t. So we can work out at different temperatures by substituting in for the capital T temperature, substituting the 36 there to get 2.81, and that's minutes. And here at 68 degrees we think it's going to take 0.0136 minutes. Thinking about the reliability of these, well, 36 is within this data range. When we did the experiment it was 2.7. We've estimated it at 2.8. That seems reasonable and it's within the data range. However, 68, we haven't got information about that. Okay, and thinking about biology and chemistry, there are different models where if you make the chemicals too hot, the reaction no longer works, and actually that catalyst or the reagent or the molecules and the microbes have been killed off and don't work at high temperatures. So it's outside the range, so we don't know if that is going to be reliable. What about for 75 degrees centigrade? Well, if the temperature is 75 degrees, our model is saying it will take a negative time to dissolve. Well, that just doesn't make sense. Okay, that's not going to be valid. How can these pellets dissolve before they've been put in the water? That's not going to work. Similarly, if it's at 0 degrees C, well, if the water's 0 degrees C, then it's ice, it's frozen. So again, you're pouring pellets on top of a block of ice, and that's not going to work, they're not going to dissolve. So do think about those real life situations and interpret it in the context of the question. Why is time the temperature the independent variable? Well, that's what's been controlled in this experiment. Temperature is the explanatory variable and time is depending on it. How long it takes depends on the temperature, so the temperature is independent. That negative 0.0873 value that was in front of the T, well, that's the gradient, and so for this we've got it, and every time we increase the temperature by 1 degree C, the time is decreasing by 0.0873 minutes. So that's in context, making sure you mention the temperature of the water and the time taken to dissolve, using the units degrees C and minutes. Finally, limitations, mentioned this above. This works for 60 grams of pellets. If we tried more pellets, then maybe it would take longer. If it would take less, it might take less. Not going to be valid for temperatures below 0 or high temperatures either. That example there, 75.